In this session, we will see one more problem in the friction. Okay, the body of weight 1 kilonewton is kept in the position on a plane inclined at 30 degree to the horizontal by a horizontally applied force F, capital F. If the coefficient of friction of the surface of the inclined plane is 0.3, then determine the minimum magnitude of the force F. So I think almost same as the last problem, that is problem number 2. You can see in the figure we have given all the marked forces already. So here, according to the problem, only we have 1 kilonewton weight of one block, and it is inclined for 30 degree. That's it. Okay, so this force F we need to mark. So we need to mark this everything, and the weight, see the weight they have marked exactly vertical. Okay, so don't consider as an inclined plane. Please always mark this weight as exactly vertical. Because of that, you have one more reaction opposite to that. Here I have taken reaction R as a N. No problem, it is R or N, it is up to you. Anything we can take. Normal reaction N means. Okay, so next, the coefficient of friction, that is mu into N. The coefficient of friction, because of the force, the coefficient of friction will happen. So here the, see here it is mu into R, that is mu into N. So already we know the friction force, that is equal to mu divided by R. Frictional force is equal to mu into R, or R is also, we can call it, we can take it as N, that is normal reaction. Okay, now it is we will see the problem. Okay, given that weight of the body is W is equal to 1 kilonewton. Already we have a weight. Next, the coefficient of friction between the block and the inclined plane is mu is equal to 0.3. Coefficient of friction between the block and inclined plane is 0.3. It is already given in the question. Next, for the minimum value of the applied horizontal force F to keep the block in equilibrium, so the block is just at the verge of the sliding down the plane. So according to the problem, the block which given in the problem, it is coming downwards. Okay, it is coming downwards. So the force of friction will act in the upward direction as shown in the figure. Here you can see according to the problem, the block is given, but there is no any other conditions like last problem. Okay, so here the block is coming down. 1 minute. If the block is coming downwards means, so definitely friction will be above, opposite to that. Okay, in order keep the block in equilibrium. The block is just at the verge of the sliding down the plane. Therefore, the force of friction will act in the upward direction as shown in the figure. So as I told, the friction will be acting upwards according to the block. Now, resolving all the forces perpendicular to the plane we have. You can write resolving all the forces vertically. Perpendicular to the plane means, 1 minute, perpendicular to the plane means it is vertical, parallel to the plane means it is horizontal. Please remember this. Parallel to the plane means horizontal, perpendicular to the plane means vertical. Okay, resolving all the forces perpendicular plane, that is sum of Fy is equal to 0. So collect all the vertical forces and just go back here, that to the figure, that is vertical forces means plus N minus W cos 30 degree you have. So here you can see plus N minus W cos 30 degree is equal to 0. So N is equal to W cos 30 degree is equal to 1 into cos 30 degree. So the answer will be 0.866 kilonewton. So here the normal reaction, see this is N is nothing but R. Normal reaction we got 0.866 kilonewton. Okay, next one. Again, resolving the forces along the plane we have. So as I told, along the plane means it is x. Okay. Resolving the force along the plane we have mu into n, that is a friction force, plus F cos 30 degree minus W sin 30 degree. Just go back to the figure. Here you can see which are the horizontal forces. See, here one horizontal force is there, W sin 30 degree, and one frictional force is there, mu into n. So and this given F, so this is already given in the question, horizontally applied force F. So you have three horizontal forces here. Okay, three horizontal forces, that is mu into n plus F cos 30 degree minus W sin 30 degree. This mu into n you can write it as F also. So after that, in second step, you can substitute mu into n. So substituting the value of n from the equation number 1, from equation number how much we got? 0.866 kilonewton. So substitute 0.866 kilonewton into mu. Mu how much? Mu, the given mu is how much? 0.3. So here you can see 0.3 into 0.3 into 0.866 plus F cos 30 degree is equal to 0.5 kilonewton. So if you substitute F is equal to, shift everything this side, that is 0.5 minus 0.2598 divided by cos 30 degree, this one cos 30 degree. So if you substitute, you will get 0.2773 kilonewton, 0.2773 kilonewton. So very important thing is we need to mark the free body diagram perfectly. So all the forces, how the friction is acting, how the friction is developing according to the original force, and according to the weight, how the reaction is developing. So after marking this, it will be easy to solve the problem. Only two steps we have, that is summation of Fy is equal to 0 and summation of Fx is equal to 0. Thank you.